Welcome everyone to today's webinar, Unlocking Hidden Value in Mine Operations Data, the Business Intelligence Challenge. My name is James Carter. I'm responsible for webinars and education programs at Wenco, and I'll be your host and moderator today. We do issue continuing education certificates for everyone who attends today's session. This webinar qualifies in most jurisdictions for 1 hour technical and formal. Formal completion certificates are emailed within 1 week of attending. You can check your local guidelines if you're unsure of requirements. Today's speakers are Eric Winsborrow, Executive Vice President of Strategy, and Simran Walia, Business Intelligence Product Lead for Wenco International Mining Systems. Additionally, Murray O'Keefe, Mine Operations Supervisor for Whitehaven's Maules Creek Coal Mine, was unable to attend but graciously joined me earlier this week for a recorded session. He has included some business cases along with some insights from Maules Creek's latest mine intelligence initiatives, and we will share these at the end of the session. A little bit about Murray. Murray is the mining superintendent for Whitehaven Coal's Maules Creek operation. He has over 10 years experience in mine operations. As the mining superintendent, he's been instrumental in pursuing significant modernization and performance improvement initiatives through upgrading fleet management systems, improving accessibility and usability of data across systems with Wenco's Avoca Mine Intelligence Platform. Murray was recently honored by industry peers with the New South Wales Mineral Council Young Achiever Award, and was also elected to Municipal Council in Gooniyta Shire, where he lives. Prior to joining Whitehaven, Murray acted as mining supervisor for Muswell Brook Coal operation of Idemitsu Kosan Company. Mr. O'Keefe has an undergraduate degree in economics from the University of New England in Australia. Simran Walia is with us today, has 16 years of full life cycle systems development experience in business intelligence and data warehousing. As the product lead for business intelligence, Ms. Walia has led the development of Wenco's business intelligence, visualization, and data warehouse product suite known as Avoca. Prior to joining Wenco, Simran was instrumental in overseeing the delivery of a broad array of business intelligence and data warehousing projects globally as Senior BI Analyst for the University of British Columbia and various roles with Cisco and Oracle. Eric Winsborrow has over 25 years senior level experience in technology, including 20 years in the Silicon Valley, introducing solutions to improve enterprise performance through next generation networking, security, and the industrial Internet of Things. Prior to Wenco, Eric was the CEO of Districts Networks, a company that developed secure next generation sensor networks for the U.S. government and industrial customers worldwide. Eric was also the CEO of Shadow Networks, an advanced cybersecurity company using software-defined networking to deceive hackers that were already operating inside government and enterprise networks. Eric has successfully brought many new solutions to market, including Symantec's flagship enterprise security product line and Cisco's voice over IP unified communication solutions. As Vice President of Product Marketing at McAfee, he conceived and launched Total Protection Solutions, the company's most successful offering to date. Eric is a sought-after thought leader on industrial IoT and IT security, and has been a keynote speaker in many organizations, including the Department of Homeland Security, U.S. Secret Service, IoT World, and has a TED Talk on cyber espionage. He majored in engineering physics and economics at McMaster University in Canada, and has an MBA in international business from the Institute for International Studies in Japan. Welcome, Eric.
Thank you, James, and thank you to everyone joining us online today. We have over 150 registrants, so obviously the topic of extracting unrealized value in mine operations data is an important one. Over the next 45 minutes, our discussion will be divided into 3 parts. First, I will speak about Wenco as a company, our people, and portfolio solutions that focus on data interoperability. Simran will then discuss the challenges mining customers face with data and our approach to mining business intelligence to help solve these problems. Finally, we will discuss several real-life use cases, including gold, coal, and other mining customers on multiple continents, including a presentation from Murray O'Keefe, who will demonstrate how Maules Creek uses Wenco business intelligence to help them extract unrealized value from mine operations data. First, about Wenco. Wenco has over 30 years of experience in fleet management and mining technology with 150 customers across the globe and growing. We are a Hitachi Group company with headquarters in Vancouver, Canada. Our association with Hitachi helps us create world-leading solutions in digital mining and the industrial IoT, including a leading visionary ranking in the Gartner Magic Quadrant for the Industrial Internet of Things. Next, about our people. Wenco employees are obsessed with customer satisfaction and helping them extract unrealized value. In fact, extracting unrealized value is quite literally the bottom line on the company's vision statement posted across every Wenco office worldwide. Wenco employees talk daily about how we can increase productivity, reduce costs, and create value for customers. Fundamental to creating value is our approach to data interoperability and open architecture. Customers have regularly told us that they need actionable data to help extract value from any mining product. With that in mind, our portfolio is designed around data interoperability and open platforms. Our core offering of fleet management and precision machine guidance allow data to be shared between systems, enabling improved performance and better decision-making with data. Our data interoperability also feeds into the rest of our portfolio, such as our safety and V2X collision avoidance systems. It also feeds into our maintenance and asset health solutions known as ReadyLine. Predictive maintenance and asset health is an important use of data for mining customers, so we'll touch on that use case later in this presentation, and we'll be dedicating a webinar in the coming months entirely to that topic. But for today, our primary focus is on how all of the data from our portfolio can be fed into our mining business intelligence platform, known as Avoca. Our open platform allows data from other systems to be fed into it, including underground mining, and even fixed plant assets and third-party data. This allows for centralized data warehouse for contextual data to be examined across the entire operations of a mine site. Our focus today, though, is on business intelligence and how customers around the world can extract value from operations data. With that, I'll hand it over to our product lead for business intelligence, Simran Walia, who will discuss the customer's needs for data, our approach to mining business intelligence, and several real-life use cases by gold, coal, and other customers across multiple continents. Simran, over to you.
Thank you, Eric. I will start with the need for analytics. Modern operations are drowning in data but starving for information. What does that mean? Each mine thrives using equipment loaded with hundreds of OEM sensors, also incorporating additional data generating tools such as fleet management systems, high precision GPS, machine monitoring systems, and much more. Mines are now able to track and store data around virtually any action in the operations. While there is abundance of data, the real question is how to make sense of it. Getting answers from traditional methods such as Excel can be time-intensive and prone to error. Excel is primarily a procedural system and not an analytical system. Data has to be copied manually from operational DB into Excel, and with billions of records to process, it is not designed to process 100 million records. The manual copying of data is also much more prone to user error. Adjusting simple charts requires several steps, hence it lacks user-friendliness. Excel also does not natively connect to many databases used in mining software. To truly support performance improvement and a culture of continuous improvement, miners need to be able to ask questions of their data with ease, investigate root causes of problems, and create scorecards and dashboards that inspire change. One of our oil and sands mine customers wanted to examine the effectiveness of having a business intelligence tool surrounding key mining business processes and asset utilization to increase production and decrease cost by adding optimal 10-10-20 rule target curve to the payload histogram that they were at that time generating in Excel. They wanted to look at the fuel delays between islands and compare crews to each other. They wanted to examine hauling productivity, which is tons per net operating hours by truck fleet by GPS haul distance. They wanted to evaluate if the mine efficiency manager could reduce operational data collection and administration time by at least 50%. Their current process at that time required a significant amount of manual effort to manage the mining records and generate reports. Visualizations of large data sets, such as haul cycles for a year, for example, was clumsy and slow using Excel, so it was difficult to make comparisons to targets. Analytics gives the ability to ask the right questions instead of reporting the same answers. It does reduce the time and effort to create timely analysis, trend reports, and effective visualizations. The need for analytics also stems from the need to combine data from multiple sources such as finance, ERP, KPI targets, weather, asset health, and machine monitoring data. Mining industry is in need of a BI solution that addresses the issues blocking the technology's acceptance and implementation. The mining industry is also in need of an analytical solution that can accommodate vast amount of geospatial data and other records. One of the mines stated that the analysis of truck route speed and individual truck speeds was challenging. For example, to see how individual trucks compared in speed on a specific corner to other similar trucks was not easy to analyze with the given current tools available to them. Our oil and sands client I talked about earlier also highlighted the data management problems that they were facing at their mine, like missing data, unclean data, and silos of data not combined. It took time for them to combine tables and performing an analysis. Perfectly clean data was a challenge, so filters were used to minimize the static, and the reasons for missing data or incorrectly recorded data were numerous. For example, wind systems that are not working properly, or poor radio network coverage, GPS problems. It was not possible to report on positional data going back more than 90 days because data was purged, so they were seeking a solution that was capable of trending and data analysis of larger data sets beyond the 3-month mark. Now, data warehousing is a solution for problems like these, where it is possible to merge information from as many data sources as needed. For example, financial data, maintenance data, weather data, and ERP data. Data is organized in an easy-to-use, reporting-friendly manner in the data warehouse, in a star schema approach for the technical savvy people. Commonly used calculation can be pre-aggregated in the data warehouse for speed, and that is another advantage data warehouse offers. Another part of the problem that this mine stated was data archiving to report on a large number of records. Historical transactions are not purged from the data warehouse after 2 years. Data warehouse is capable of maintaining all history for trend analysis. Data warehouse also eliminates the problem around data quality. It ensures data quality whereby data is validated and cleansed during the load into the data warehouse, and data issues are recorded for analysis. The exception handling rules can be designed and put in place to ensure reliable quality data is available for reporting and analysis. The data warehouse ideally then feeds into a series of web-based dashboards that show the mine's KPIs and their patterns. Maps, charts, and other visualizations can be developed to create a link between equipment, activities, geography, and other factors on site. Wenco has gone about and created a business intelligence suite called Avoca to address the needs of the mining industry, which offers the data aggregation, storage, and analysis functions of a business intelligence platform specifically built for mining. I'm going to talk a little bit about the data warehouse qualities or the features of a data warehouse that makes it a very strong contender at every mining site. So data warehouse is subject focused, which means it is organized around major subjects like operations, equipment utilization, and production performance. The data is integrated, which means it's constructed by joining multiple heterogeneous data sources with data cleansing and integration techniques applied. A data warehouse is non-volatile, which means it is a physically separate source of data and it is a read-only single source of truth. A data warehouse is time variant, which means it stores data over a longer period of time, offering insights into the historical measurement and trends. At another mine site, the issue was that the haul trucks were stopping at an intersection and mine manager wanted to get a better idea of what was happening in terms of which trucks were those, the operators of those trucks, how long they were stopping for, and whether the trucks were loaded or empty during the stop. The speed map report, which can have the mine image behind it in case of the real mine data, but this is showing you a report with anonymized data, is highlighting the stopped statuses. The image on the left that you see is narrowing down on part of the mine with two intersections where the trucks are in haul stop status. The second image that you see highlights haulers in haul stopped and empty stop statuses to get information of the time the equipment stopped for, which is in seconds, by operator and by equipment. In speaking with mines, there are several key areas where they were either having little insight in operations, or if they did, they were expending significant hours with complex data analysis work to gather these insights. I'm going to share a couple of examples with you here. One of the coal mines were interested in tracking the coal mined as a tonnage from the pit through stockpiles or into the prep plant feed bin, showing trains sent per day to port stockpiles, and overview dashboard of the entire process for management. Another gold mine in South America had a scenario where all equipment operated and maintained by the mine had a targeted number of hours to operate between stoppages for preventive maintenance. And if the unit is not stopped for preventive maintenance and it goes beyond the target hours, that trend needed to be identified. If a unit is stopped for preventive maintenance too soon, that trend also needed to be tracked because it prevented the equipment from achieving maximum operational effectiveness. The solution for this analysis was to gather the equipment status data from FMS and analyze the mean time between preventive maintenance and mean time between repairs for each unit individually and the fleet in total. This offered some view of how healthy a unit was, if it was being abused, or if enough time was allowed for preventive maintenance or repairs. In many mines, tires are scrubbed before they are worn out because of tread separation and damage. And the root cause of this could be anywhere from road conditions to overspeeding by the operator on corners or elsewhere. Tire monitoring analysis reporting on TKPH overspeed areas, a speed heat map report can be designed to see where and which operators are speeding, running corners very fast. Monitoring this can reduce the truck downtime for tire repairs and increase the overall life of an equipment. What you see here is a payload versus payload target comparison, and this dashboard compares haul cycle payload versus payload targets and the factors affecting the payload. The histogram that you see shows the number of haul cycles within each payload percentage of target bin and within the target range in green. The trend over time of haul cycles within, over, and under payload target is shown to see if the payload versus target is improving or not. The bottom charts on this dashboard that you see shows the percentage of payload versus target for several factors that influence the payload, for example, operator, equipment, etc. The data points in the charts can be selected to highlight or filter other charts by the selected items. This dashboard that you see is to investigate the speeding equipment and operators at various map locations. This dashboard identifies equipment or operators outside of average speed ranges or expected speed at various map locations. The data source for this dashboard is the equipment event records from FMS. The filters on the right-hand side can be used to select mine, date, equipment type, and then click points on the speed trend chart to view the detailed map of equipment speed points. Using the map buttons to zoom in and select multiple speed events and see the equipment and operator associated. Select a speed range using the slider control to filter out equipment outside the selected speed range. The average speed for each equipment and for each operator over the report period and for the selected speed range is shown below the map. Selecting an equipment and/or operator in these lists filters the other charts. The red color intensity that you see on the bar indicates higher average speed. You may select a data point in the speed timeline chart to view the detailed map of speed recordings on the selected date. You can use the filters on the right to select the equipment and appropriate speed sensor, a name which is, for example, GPS speed here. With these couple of examples, I wanted to highlight how disparate systems can be brought together to create a holistic view of operations, spot trends, and drill down the root cause affecting the mine's performance. A business intelligence tool specifically tailored for mining industry which is user-friendly, provides intuitive insight, does the heavy lifting of correlating mine performance factors like geospatial data, ore body quality, equipment speed, spotting time, machine performance, shifts, weather, etc. is key to unlock the hidden value in mine operations data. This concludes my presentation. Thank you so much for listening. Now, Marie O'Keefe, Mining Superintendent from Maules Creek, Australia, will share some of the transformation he's led with his team at the site through BI and share with us a few use cases. Welcome, and over to you, Marie.
G'day and thanks, Simran. As explained, my name is Murray O'Keefe and I'm one of the mining superintendents for Whitehaven Coal at our flagship Maules Creek operation. Well, like everyone, I have many areas of responsibility, but realistically, this day and age, I'm mainly playing around with sort of analysis and improvement projects and looking after dispatch and the fleet management system, mainly from a people and processes perspective, not a technical perspective. We have been using Evoca in a serious fashion on site for a bit over 12 months now, and we've recently just committed to purchasing the product outright for a second year and using it long term. There's a few reasons for that, but there's a really succinct example that I'm going to go through. So I've just flipped the screen onto a haul cycle variability and shift details. And this is one of the first dashboards we created as a site with help of the Evoca team from within Wenco. So it's modelling by a dig unit, and the 5 dig units you can see there are our ultra-class Hitachi EX8000, so our big girls loading ultra-class haul trucks. And what that models on a per shift date is what the variation in the average haul cycle time is. So we use Wenco's dynamic dispatch, so trucks get flipped around between different dig units, but for cycles where a truck gets loaded, hauls to a dump and returns to the same dig unit, you can see that if we look at June the 17th for 261, there's a 28.3% variation in that time that it's taken. Whereas you can see for, again, just looking at 261, the average is a lot closer to 11 or 12%, sometimes even better. So this dashboard's allowed us to pick out, outlier days or shifts. You'll notice there's 2 results for every day, obviously day shift, night shift. And if you look at that, again, I'll pick on that night shift from the 17th of June on 261. That allows myself and the other superintendents to dive into that with both the pit supervisors and the dispatch supervisors and try and find an understanding of what's gone wrong. It also allows us, if we blow that time period out, to track a trend over some time. And this is certainly something that we've worked on hard over the last 12 months to drive positive improvement. When you see something like this, you should be starting to ask questions and go, well, what are some of the factors that delve into shift variation? Now, an absolute outlier like that 28%, something's gone wrong. There's something happened on that crew or that shift that's gone wrong on that circuit. Whether it be an intersection change or a truck breakdown or something along those lines. But the biggest thing or the biggest trend that, we've established that contributes to haul cycle variation is actually operators. So I flipped onto another slide, and this is the subsequent dashboard that initial one got us to create. So about 12 months ago, we created the top view you can see on your screen now, which is an operator box and whisker. On the left-hand side are operators whose average or mean, if you like, shift or haul cycle variation is quite low. In other words, their variation is small and they're generally fast. So that green line that you can see running across there, that's the average. So that's the average, variation and speed for a haul cycle. This is a pretty complicated and clever graph. It's comparing apples with apples. So it's comparing operators who've had, a certain amount of training, a certain amount of loads in the data period or in the time period that it's set from, and it's only comparing like cycles with like cycles. So 12 months ago, you can see we had quite a large spread between our fastest operators and our slowest operators, and we also, all our operators, even our fastest operators, had a real variation or a lot of variability in their haul cycle between their fastest and their slowest, and then, you look at their outliers too, which were all over the shop. Drop down, fast forward 12 months. Now, out of the actions that we've created from that top screen, which is more than anything, it's been picking operators who are in the back half of that graph and mentoring them. So putting trainers in the cab with them and mentoring them about how they can be more consistent, how they can pick up their cycle time. And then even for the better guys, it's just showing them, deleting every other name and only showing their name and just showing them, this is where you fit. You're in the mid-pack. If you're looking for progression in your career and upskilling, you need to get in the top 25%. You can see 12 months later on that lower slide, we've driven a drastic change. So you're still going to have 50% of your operators better than average, roughly 50% not as good as average. However, you notice that it's a lot flatter and there's a lot more operators clustered around that mid-pack. You also notice that the variation, even the variation between some of the lesser operators, but particularly, say, the top 75%, which are people who are experienced, they're not trainees, they haven't just been here 5 minutes, that variation has tightened up something chronic. And that's due to the sustained effort that this data has enabled us to put into individuals and train them. The other thing we'll notice is the data doesn't show what the mean shift performance is doing. And I can 100% guarantee that our shifts are getting bigger. We've added more dig units, more haul units, more operators, and both our raw production and our productivity on the shifts has improved, quite a lot and increased. So again, it's just more cream or more, efficiency that we're using Avoca to cream out of or drive out of our system. The next couple of slides I'm going to show you doesn't look like Avoca at all, and that's because it's firmly some graphs and charts made in Excel. So I'm looking here at waste, actual performance versus forecast performance, coal, waste. I'm going to flick through to the next slide, showing you some graphs and charts that come out of Excel. The reason I'm flicking through those two things and showing you is I thought it was worth to show you what we're doing next in Avoca. So this is currently an Excel document where we've got an engineer who we're paying, I reckon it's taking him about 12 hours, which is a day and a half of his week, to create this analysis in Excel. And that is looking for data, then entering the data into an Excel model that he's created, and then presenting it to myself and the rest of the management team for analysis every week. So we've just purchased a few extra Avoca licenses, and like I said, have committed to it for the life of mine. And part of that is to give this engineer who's created this, who's our dumps and haulage engineer, the ability to build this report as an interactive dashboard in Avoca, so he doesn't have to do the data entry. That's going to mean that instead of paying him 12 hours a week to do data entry and try and create this data for myself and the management team to scrutinise and see how we went according to our plan, we're going to be paying him to run this report on a Friday morning and spend his hours, and probably only give him half a day to go through and provide analysis. So he'll be able to see what we've done, see how we've compared against forecast, so the agile plan and actual, and then dive into it and provide analysis. So when we walk into our Friday management review meeting for the week that was, instead of us sitting around a table in that meeting and trying to review it, we'll sit there with the data and the engineers considered analysis of what went wrong so we can quickly provide actions to come out with that. That's really the value, more than anything we're driving out of Avoca. It's the same if I flick back to this box and whisker plot on horse cycle variability. One of our engineers built this in Excel, built a way to measure this data and compare operators, but every time we wanted him to run this report, it took about 3 days for him to modify the model, enter the data, after finding it all and putting it together. So why are we paying an engineer to do that for 3 days? It means we're going to do it once or twice a year, but now it takes 30 seconds to run on Avoca, after 1 3-day build period from the engineer. That's the advantage we're driving out of this, and there's, some quite real positive benefits and cost savings for our business. And more than anything, it's about creating mental headspace for management and your engineering or business improvement team to do what you're paying them for, as opposed to being data entry clerks.
Thanks very much, Murray. A few housekeeping items before we move to Q&A. Please stay connected with Wenco. You can follow us on social media, get several weekly industry updates via LinkedIn, Twitter, and Facebook. This webinar will be recorded and distributed in about a week there, so please keep an eye out and share it with your colleagues. You can always learn more about Wenco at www.wencomine.com. You will also find an orange request information bar on the bottom of most pages should you wish to connect with us. We do want your feedback, so please let us know what you think of today's webinar. We'll now proceed to question and answer period. Additionally today, Jason Clarke, our Technical Sales Director, will be joining us.
So with that, we'll now proceed to Q&A. One question here, this looks like a good one for Simran. What are the most common use cases and where are companies finding the most cost savings or specific performance improvements with BI?
Well, what we have heard from the latest customers has been quite varied. Where BI really helps is anytime you want to efficiently look at the large amounts of data, especially around the single shift, say over a quarter or even the life of the mine. Additionally, building dashboards that can be referenced is very good for supporting performance improvement initiatives, scorecards, and behavior change. We have had mines doing various investigations on loading. One in particular had a difficulty identifying underloading despite using fleet management systems due to variability in the haul units being paired with various shovels. They were able to build a dashboard and generate a scorecard for shovel operators, identifying loading percentage per hauling unit and identify retraining opportunities. On the haul truck operator side, the customers were doing things like identifying out-of-limit behavior by operator on a scorecard, which has proven to significantly improve and reduce downtime, component, and tire wear.
Thank you, Simran. I'm actually going to fold two questions came in here that I think Eric can probably respond to well. So the first one is you spoke about adding contextual data to operator performance. Do you have any around maintenance? And this is a little bit loaded. Someone asked where they could demonstrate benefits in terms of money. And certainly maintenance-related BI applications are one area where there's significant cost reductions. So Eric, over to you.
Sure. Well, first of all, about the contextual piece, well, not just for maintenance, for everything, but really to make any sense of data, context is everything. Customers can't just get raw sensor data and derive any meaning from it, quite frankly. No actionable intelligence can come from just raw sensor data. They need to know all kinds of other information that may come from different sources. So they got to know, for example, unplanned downtime, but you need the fleet management system to tell you when was the thing working, when did it have downtime. They need to know other situations like what were multiple sensors. It's not always one sensor gives a piece of information. They want to know where was it? What was the location, the geospatial location? Who was the operator? All of that is contextual information, and even third-party information they want to start bringing in. You think about thermography or oil analytics or even ERP systems, because that's where all the costs are. How expensive was this, which I guess leads to the second one. If you don't have all of that data, you can't make good decisions. You can't see when something is going to happen again, and that's the whole point of predictive maintenance. You got to see what didn't work, see the variables, and see what does. I did talk about the connection to ERP systems and costs, so this is an important piece because the whole point is extending the life of valuable equipment, but making sure that you don't waste a lot of money. And if you're just following the OEM maintenance schedules, the preventative maintenance schedules, you probably have thousands of hours you're probably wasting by replacing parts or components because that's when the OEM told you to do so. You want to operate as long as you can. Tying into the ERP systems also knows the cost of replacement. So if you go too far, then obviously what could have been a $200, $300, $400 replacement, I'm actually using real data, I can't talk to customers, but we saw things where if you caught something well enough in advance, you're talking about several $100s for a part versus an engine component, which usually costs them $250,000 or $500,000 to replace, and variations on that theme. And what we've seen is often more than a 10x increase in costs because they couldn't anticipate when there was going to be some sort of downtime. So there's real value to being able to do conditions monitoring, comparing it to other data, and being able to predict when maintenance is actually necessary.
Excellent. Thanks, Eric. There's some great questions coming in. Please do keep them coming. So how does Wenco go about product development, the visibility with actual complexity and ease of use?
If you're just talking about Avoca, the way we have built the product is by researching and talking to the end clients, that is the mines. This product is not built in silos, so it understands the complexity. And if you see the pre-built dashboards that come with it, the reports are quite complex, but they tell a story of the data in a very simple way. So the complexity is not the issue. It's about understanding the complexity and visualizing it easy manner. And I think if you break down a complex report into smaller pieces, it just becomes easier to build it one step by step. And the reports are built that way to understand a mind's mind.
Yeah, and I think it's Eric, adding to that, I think that's why it's important that it's a company with experience and many decades experience in mining actually creates the BI platform. Because if you are, an IT-focused company, your Silicon Valley type company, what have you, you don't understand the complexities of mining or what matters most, right? So when we designed Avoca, and this is why Simran talked about the 80 templates, well, the 80 templates are specifically mining customer related. So that takes out some of the complexity right there. Tableau is a fantastic tool, but on its own, it isn't useful if you don't have, again, the context to the needs of mining. And that's where a lot of development time was spent. What matters? Who cares? Who's going to use it? What would they use it for? And that's why those templates got created. So that's actually how you make complex things simple.
That's great. Thanks. Oh, here's a good one for Simran. It sounds like you alluded to being able to use this software with other systems. Do you actually sell and support it if we're using a different FMS system, fleet management system?
Thanks, James. The way you can consider Avoca is it's a plug-and-play software. So it can plug into any fleet management system, like modular. Right now, it is being sold with combined on Wenco FMS, but it can sit on any fleet management system, as a matter of fact, and it will show the visualization. The data will come to life from any fleet management system.
Excellent. Thanks, Simran. There was one question, a clarification in terms of what inputs were creating the weekly haul analysis.
We have it for almost 10 years. We can store data warehouse data for almost 10 years, and that's what is feeding it from the Wenco FMS. So that is how we have been able to build the trend analysis and to analyze the productivity of the hauling units.
Excellent, thank you. Another fairly technical one, when we don't have a PLM in the hauling units, is it possible to capture the loading time and queuing time in a Wenco FMS?
Yes, we can do that. We can build complex analysis and also customize formulas where we can calculate various calculations within the data warehouse, and we have been doing that. So we have dashboards around that as well.
Excellent. What is the implementation timeline and the process, and how much time is required before I'm able to make some informed decisions with my data?
Well, first of all, when we introduce Avoca at any site, we do give them an option to have a trial set up on their at location or in cloud. Once they have kind of played around with Avoca based on their data, we do, and they agree to buy Avoca. The implementation time is around a week, which also includes the installation and the training related to the product. And so in a week or so, they're up and running using the product independently. We do offer certain development hours as part of the Avoca package, so we kind of handhold them and we kind of bring them up to speed to use Avoca independently, but around 7 to 10 days maximum.
Excellent. There's a good question here for Simran. Based on practical mining constraints, we need to benchmark or decide which KPI varies from mine to mine. Can we perform benchmarking, or what would be the ideal operating parameters for this through Wenco?
So again, Avoca is a product that provides a baseline, and every mine site can build on it. Every mine site has different KPIs that they use, and this product is fully customizable. And we also handhold and kind of guide through and train how to build their own KPIs, and then go and build their own dashboards and reports, or modify the existing ones to repurpose them.
Excellent. Another question about weather data. Would Avoca be able to digest and generate reports using weather data?
We already have dashboards that digest weather data, and it also shows the efficiency based on the weather or the rainfall and everything. So we have one dashboard that does that already, and it can digest basically any kind of data. This is a plug-and-play software. You can have different sources coming into the data warehouse. where it makes sense, we make joins to it, and you can use the metadata, or it can be ERP or financial or any kind of data.
Excellent. There were two questions that came in about Power BI. One is, how does it compare to Power BI? And can you expand on the reasons for not choosing Power BI? And two is, we have a few people in our company that are strong Power BI users. How long would it take them to get up to speed with Avoca?
So when we were analyzing which BI product to really use, if you look at the quadrant, the Gartner quadrant, Tableau comes on high efficiency and good productivity. What it does is it's very independent product where people can get up to speed and start using it basically without any technical knowledge. And that actually drew us towards choosing this product, because a lot of mine sites don't have IT and do not have technical, and being mine managers or different levels at the mine site using the product, it has to be a product that can be very easily adapted. And Tableau is also capable of reporting on 100,000 or million records, geospatial records within a matter of seconds, which Power BI cannot do. And so there are these restrictions which we wanted to give an edge to the mining experience and the reporting world. And that's why we chose Tableau. Power BI definitely is a cheaper product, but then the quality also is not that great. You cannot really justify cost versus the quality that you get. The geospatial analysis is very key in mining world, and Tableau fits perfectly there as a product that would take the experience and the analysis to a next whole new level. So switching is we will have to rebuild the analysis in Tableau, which is very easy. As I said, this tool is very adaptable, and it doesn't really need technical knowledge to really learn this tool. It is very intuitive. It has a lot of options which you can choose, which doesn't need you to be a Tableau expert to really use it. A lot of mine sites where we have sold Avoca, they use it, and they are pretty much fairly very independent, and they do come back to us if they want some complex reporting done, but on a day-to-day basis, they're fairly independent and they're building excellent reports on their own.
That's great. Thanks, Simran. Can you clarify also, someone asked if the full suite of dashboards is supplied by default?
So a part of the Avoca package, it comes with the data warehouse, the ETL that comes with it, and the suite of visualizations, the pre-built visualizations, which is around 80 or so, which is focusing on productivity or equipment operation, equipment efficiency, and various factors like payload and stuff. So this is a suite of 80 visualizations, dashboards that comes pre-built and as part of the Avoca package when they decide to buy it.
Excellent. A good question here. Our site has several really quite complex spreadsheets that we set up to track key operational data. Can these sorts of things be replicated? How much experience does Wenco have customizing these? So
again, if they have these complex reports, we have been building them ever since we built the product, and that is the idea. When a customer buys a Avoca package, they do get certain number of development hours, which they can use to either create the customized reports, or they can use those hours to customize their ETL, or we do also offer our consulting services post those hours are exhausted to help the mine sites to build their reports and transition into Avoca.
This is an interesting one. What is the minimum fleet and mine operation duration required to get a reasonable return out of this package? Hey, Eric, do you want to try and tackle that one?
Yeah, I can try. I mean, we've seen data show up in the first few weeks because sometimes we can import data that they've already had, like the spreadsheets, as Simran was saying. It's very easy to take data they've already got and look at it. So we found sometimes even on the first week of starting to import data that might already exist in multiple different sources, and finding needles in haystacks that they couldn't find because they were just having raw people look at spreadsheets. So we've actually had situations where we find it right away. Let's assume you're starting from scratch. Most customers don't. They usually try something like a cheaper product, like Simran was mentioning, or spreadsheets is probably what they've been doing for the past decade. But let's pretend it's starting from scratch. Probably it takes a month to 3 months to really start to see some real trend. You will find some things right away, but we're finding that when we start to look at 2 or 3 months of data, then you start to see trends come in, and that's when you start to know you have something for real as opposed to just outlier data.
Excellent. Thanks. Here's a good one. It sounds like Maules Creek is quite advanced in that they adopted internally quite quickly and worked this into their strategy. What if we feel we need more support in both adoption and strategy to extract value from this? Is that supported?
Yeah, that's a good question. And actually, Simran partially answered that already in the sense of when anything that we do with our solutions, especially when you start to look at business intelligence solutions like Avoca or predictive maintenance solutions that combine both ReadyLine and Avoca, we will provide consulting hours. We are actually moving to a solutions approach, and have been doing that for a few years now, getting away from people that are just selling product or technology or software and actually solving problems. I'd already mentioned as a culture we're obsessed with helping the customers extract value, but we're really doing that in terms of the solutions we bring. So whenever you buy a solution like that, it comes with some subject matter expertise that helps you do pre-implementation planning. We literally come, take a look at your operations. What are your processes? What do you do? What do you most want to accomplish? What systems do you have in place now? So that when you do purchase any of our products, but obviously we're talking about business intelligence, it applies across the board, we figure out how is this going to be configured? And what do we need to do to plan? What do we need to do when we actually implement this and configure it? What are some dashboards you're going to want to have? Take a look at our AD templates. What should be customized? So there's some configuration thought. And then after the fact, not only would you teach you how to use it, but if sometimes you just need an extra set of eyeballs because you're looking at things, but you want some subject matter expertise to help you look at the data, we will do that as well, typically remotely, sometimes on site, or a combination of the two. And we'll help you find things or even tweak the configurations and report based on the first couple months of operation. So it really is a solutions approach where we try to add value.
Excellent. That's great, Eric. I'm going to wrap up here. It looks like there's a few technical ones that came in, so I'll send these over to Simran. There are some questions in terms of clarifying GPS specifications required to get some of the spotting times that we were getting from Whitehaven. Maybe if you could elaborate on what kind of GPS data we were collecting there, what format it was coming in?
It comes in a lat-long format, and we can actually get GPS data in any format, and we can convert it in our data warehouse into lat-long format and display it in that format or whichever format they have. So as I said, Avoca is capable of ingesting any type of data in whichever format it is, and then we can do the conversion if they want, or we can just display it as is.
Great. Thanks, Simran.
We talked a lot about kind of interoperability of the Mine Performance Suite at the beginning, and someone did ask here, you mentioned that Wenco is an open platform. Can you mention a few other platforms that you're compatible with? And I'm going to give this one to Jason, actually.
Sure. So Wenco being an open platform, that's been a philosophy of Wenco's for 30 years. We built on Windows, obviously, and our database is an open SQL Server database. So I'm speaking more from the fleet management side. Customers own their data. The computers that we use on onboard equipment are components off the shelf, which means that they're basically Windows computers. We're not going to corner customers into using one specific platform. So interoperability is really sort of baked in throughout all of Wenco's products.
Yeah, I'm going to add in a strategic thing for any of those that are on the call and are doing planning for the next 10, 15 years. They know that mining industry is changing. It's data-centric. You know, the issue that I've seen in 25 years, and not just in mining, but I see it in mining too, is there's two philosophies from the vendors. One, I'm going to be proprietary. I'm going to make things work for myself. I'm going to make things work with our own data, with our own sets, with our own products. And it's going to be fantastic. And in fact, I may not quite share all of that information from anybody, third party. That is in my mind, a failing strategy because the Internet of Things and data is about ecosystem. You're not going to have a one-size-fits-all. You're going to have multiple components. And a lot of vendors are thinking only of how do I make our data work within our set. The winning solution is really the open system. APIs, openness to share data to somebody else, openness to take data in. That's really Hitachi's philosophy and Wenco's philosophy. And I think that's a winning one for the future because all of the customers we've been dealing with when we implement these BI solutions or the predictive maintenance solutions is they're a bit frustrated because of the work they have to do to make all of these different types of equipment and systems, share data. And that's probably not a winning strategy down the road. So I think that's an important decision factor. It's not doing what you did for the past 10, 20 years. It's what are you going to do for the next 10, 20 years that I think matters.
Excellent. Thanks, Eric.
There's an interesting one about clarifying the three-tiered structure. It's my understanding that a lot of these packages don't have three separate layers. They use visualization on top of existing infrastructure. I've been told our infrastructure is pretty good and that we can store a lot of GIS and FMS information, FMS being fleet management. Do we really need a data warehouse as well?
And James, I want to jump in and add one other thing. It's just repeating what Murray had already mentioned to us personally and also in the webinar, that he has an engineer, highly qualified, skilled engineer, spending almost a day a week just gathering data and putting it into spreadsheets and trying to just assemble the data, not adding a lot of value, just trying to get it together. And he does that every single week. And according to Murray, now what that used to take him a day takes 10 minutes. So now this engineer can either spend time finding the why behind the what or go off and do other value-added work. So what's the ROI on a data warehouse just to be able to save somebody, 20% of their time?
Excellent. Thank you. One clarification, which I'm pretty sure we've addressed here with the data warehouse, but they were asking how far behind real-time is the data in Avoca?
So in the data warehouse, we can have the refresh cycles customized as per the mine sites, but typically we do it twice a day. Is recommended right after the shift. The ETL kicks off and it loads the data. So twice a day, or the earliest would be 2 hours.
Yeah, and let me add to that one. If you remember when I was introducing our portfolio and how it is all about data interoperability and how all of these systems communicate data amongst each other and then up into Avoca for the business intelligence side of it, the purpose of BI is to be able to do a larger, more scalable, time-based analysis. But all of our systems are real time. So if you look at, for example, the fleet management system or ReadyLine, which is the asset health maintenance system, all of that data feeds into the monitors and into the reports, the alerts that we have in real time. So all of these subsystems have their own dashboards and capabilities where if things are important operationally, all of that data is in real time. If you want to start working things in because you like, let's say, KPIs, I'll use maintenance as an example again, where you really do want to have certain KPIs on a dashboard show up. There's nothing really restricting us from offering BI reports in that format in real time, but we tend to allow the individual technologies to be real time in and of themselves.
So I will say that, Avoca is an analytical system and not an operational system. The earliest we recommend doing is 2 hours, and typically it's done twice a day, right after the shift ends.
Excellent. Thanks, Simran.
Many thanks to Simran, Eric, and Jason, and a big thanks to our audience today for taking your time to join us. Thanks very much, everyone. Have a wonderful day.